Hi guys, welcome to the populations lecture. Today we're going to be talking about the size, characteristics, and growth of a population. Here's the vocab and objective. So this week you're going to explain how biotic and abiotic factors impact the carrying capacity in a population. And you're going to use data sets, simulations, graphs, and calculate the changes in population size given a situation. You're going to include birth rate, death rate, immigration, emigration, and figure all that out. Here's the 10 vocab words that you wrote in your notebook last Friday. And we're going to start lecture. Remember, you're writing on one side of your notebook, and then you're going to do the drawings on the other side of your notebook. Okay, so let's start with the characteristics of a population. What makes something a population? So the first one is its geographic range. So where exactly is the population that we're talking about? Second one is the growth rate. So how does the population grow, right? Does it grow fast? Does it grow slow? What are we looking at? And how is the population changing? Next one is population density and dispersion. So how many individuals are in the population? How are they kind of separated? And like where are they located? And then lastly, age structure. What's the age of the population down to gender and specific age groups? So first, density and distribution. So you should have something like these drawings here, not the pictures at the top necessarily, but the graphics at the bottom, the diagrams at the bottom, those are what you need. You need to know which one is which. So density and distribution is the distribution of a population, how it's spaced out across an area. So it can be random, and this one right here is random. Kind of randomly spaced out. Think of like squirrels, right? They're like randomly around, sometimes together, sometimes by themselves. It can be uniform, so evenly spaced out. That would be this one, that's uniformly spaced out. So this lots of times is things that have certain ranges or territories, so they're a certain amount apart. Think of like students in a classroom, right? Or it can be clumped, so packed together in groups like schools of fish. Okay. Next, population growth. So population is going to change based on four things. First, birth rate. So birth rate will make population sizes go up because people or organisms are being born. Okay. Death rate will make population sizes go down because things are dying. Migration is the next way we talk about it. So migration is just the movement into or out of a population. We have more specific vocab than just the word migration. Migration you probably know as just common terminology. The science word for it, we have immigration, which is movement of individuals into. So immigration with an I, into with an I. That's moving things into a population, and this is going to increase the population size. And then we have emigration with an E, and I want you to think of exit with an E, that's moving individuals out of a population. When you talk immigration or emigration, lots of times you have to mention like two things. Like you can say I immigrated, or I immigrated to our class, but I emigrated from somewhere else. Does that make sense? Like I have to emigrate from one place to immigrate to another place. I have to leave one place to enter another place, because if I'm not leaving someplace to get somewhere, where am I coming from? Then it would be like a birth or a death. Make sense? Emigration is going to decrease the population. Next, growth rate. So to figure out the growth rate, there's some like equations, I guess you could say, but it kind of is common sense. So if birth rate is greater than, remember this is greater than, if birth rate is greater than death rate, the population will increase. If birth rate is equal to death rate, your population will be stable. If your birth rate is less than your death rate, population will decline. That does not account for immigration or emigration. Clearly, that can change a population also. So when we look at the growth of a population and how it changes, we just talked about why. So how it changes and how we look at that, there's two different ways it's going to change. You can have exponential growth or logistic growth. Do this as like two halves in your notebook, okay? Exponential growth. So this is when a population grows rapidly. Exponentially is rapidly, okay? It looks like a J on a graph, and the picture looks like this. So we have kind of a stable number right here, and then we skyrocket up, okay? Bacteria do it because you have 1, it divides into 2, 2 divide into 4, 4 divide into 8, 8 divide into 16, I'm out of hands, 16 divide into 32, right? So it grows exponentially because it's doubling itself. It's not like people who 2 people have 1 baby. Bacteria, 1 bacteria turns into 2 when it divides, right? So exponential rate is going to go really fast once you get a bigger population. The next one is logistic rate. This is when the population grows fast at the beginning, but then slows down and finally stops. For exponential growth, there's usually some kind of limiting factor, right? Limiting factor is something that causes the population to reach the capacity of the area, okay? So we have 3 different phases to this growth, right? We have this phase 1 where our population grows rapidly. So that would be this area. Let me get like a highlighter-y thing here. That would be, nope, this. Here we're growing rapidly, okay? This is rapid growth, okay? Right here, we stop. Right here, we slow down, right? And then when we get to here, we've reached carrying, ooh, I don't like that because you can't see through it. Then right here, we reach carrying capacity. It's where the limiting factor has been reached. 1 second. Ooh, sorry. It's when the limiting factor has been reached. So something has stopped the population from getting bigger. It could be size, it could be food, it could be mates. Something is making it so like it's not able to sustain a higher population size. You should have these graphs drawn in your notebook. Okay, so carrying capacity, a little bit more on it. This is the largest number, and for carrying capacity, we're talking about this area here, maybe yellow. This area here is carrying capacity. Okay, it's when the largest number of individuals that an environment can support, the most that it can support comfortably. So first what happens is the population is going to go above carrying capacity. So a population ends up overshooting carrying capacity. You have too many individuals, right? When you have too many, a bunch die and you end up underneath it, okay? And then you end up a little bit over it and it kind of wiggles back and forth at carrying capacity. So when we go too high, many members die or starve, population size drops, goes below the carrying capacity. Then we're going to fluctuate or go back and forth above and below the carrying capacity. At carrying capacity, our death rate and our birth rate are pretty much equal. So growth kind of stops. Limits to growth. So what's going to stop this growth from occurring? So what's going to stop it is anything, well, limiting, so it's naturally limited. A limiting factor is what stops it. So our factors can include competitors, parasites or diseases, overcrowding, predation, and herbivory. Predation and herbivory, which is predation on plants, right? Herbivores attack plants, herbivory, new word. Weather, fires, all that can limit your growth. Different types of limiting factors. So when we talk about limiting factors, some of them, density dependent factors, okay? These guys are going to depend on these ones. Density dependent are factors that occur when your population gets too large, right? So competition, right? There's not enough food, we're going to compete with each other. Predation, there are too many predators, they're going to kill you. Parasites and diseases, right? When populations get too big, they spread disease and they have parasites and stuff like that, and then stress from overcrowding. Density independent factors are things that are going to limit your population size, but don't have to do with how big your population is. This is like natural disaster things, okay? So regardless of how large the population is, if there is a flood, it's going to kill a certain area. If there is a fire, it's going to kill a certain area. If there is a drought, a certain area dies. It doesn't necessarily matter if there's a whole lot or a whole little of organisms. Some more density dependent factors. So specifics about them: competition, populations become crowded, organisms compete with one another for water, space, sunlight, anything essential. For predation, populations in nature are controlled by this. The prey of plants is called herbivory. We said that earlier. As predator prey increase, as predator populations increase, they kill more prey. As prey decrease, the predators end up starving. So then there's less predators, then prey increases, and then predators increase, right? So they kind of cycle with each other, because as you have prey, you end up with more predators. And then when the prey goes down, the predators go down, right? It causes a cycle in that population. You can see that lots of times with hawks and bunnies, like in your neighborhood. If you have a lot of bunnies, the next year you have a ton of hawks. And then if you have a ton of hawks, the next year you have less bunnies, right? Last one of this, parasitism and disease. So the closer the populations are, the higher chance of spreading disease and parasite.